What is ABCD right now in the givens? Okay, guys, there's no properties. Don't make this a two-step proof and say, oh, BC is congruent to DA because opposite sides are congruent. No, it's not a parallelogram. It's a quadrilateral. You have no properties other than it has four sides. So please don't think it's going to be two steps and we're done. So let's discuss, how do I get BC and DA congruent? All right, well, let's go to my givens here. Wow, we got a lot. FG is congruent to EG, and AG is congruent to CG. B is congruent to D. Got it. A lot going on, huh, guys? All right, right off the bat. Woohoo! I know what some of you are thinking. Wheels are spinning. Oh, hey, that's a parallelogram because the diagonals bisect each other. Hate to break it to you. There's a problem with FE. It's not a diagonal. Okay? It's not a diagonal. So don't think diagonals bisect each other. That's garbage. All right, does everyone see that? It looks like you can do it, right? But FE is not a diagonal, so that's out. All right, so how can we get BC congruent to AD? I don't want to prove it's a parallelogram till part B. So maybe, what have we done in the past when we had to prove two line segments are congruent? Proved what congruent first? Triangles, yeah. So what triangles contain BC and DA? It looks like the larger ones here. So can you get the larger ones congruent? Well, let's see what we, okay, hold on. Let's see what we have so far. So if we can get these two, and that's not what I wanted. If we can get these two congruent, then I could say CP-CTC. So what do I already have? Angles and sides wise. What do I already have? Pair of angles. I got B and D congruent. So I got a pair of angles there. What else can you write in? Side AC congruent to itself, reflexive. And is there any other thing we see up there? And remember, it's not a parallelogram. You don't have these properties to work with yet. It's still a quadrilateral. Darn it. Anybody see any more sides or angles in those two triangles I can work with? Either do I. So it looks like right now we can't prove those triangles congruent, huh? But that proof doesn't stop. Might not be those two, but are there any others up there? Yeah, I can prove these two right here. They're almost done. The only thing I need to say is what? One is congruent to two. Vertical angles are congruent. Whew, we got a lot going on here. And then those two triangles, let's make sure we just name them correctly. What do I have? Triangle AGE. Congruent to, if I go AGE, I got to go CGF. Hey, what method are we going here? Let's start it off with number 8. Thank you. Wait.
Yes, side angle side.
You good?
Yes, side angle.
Thanks. Side angle side. Well, why do we want to prove those two congruent? So you can get a pair of angles or sides that are also in this yellow and purple one we need. All right, dig deep, dig deep. Can you find a pair of angles or sides that are in both pairs of triangles? Full angles, full sides. And I made it kind of easy here for you, I thought, by putting numbers there. Sinead. Angle 3 and 4 are in both. Everyone agree? There we go. So angle 3 and 4 are congruent. Reason? CP, CTC. And now, aren't the bigger triangles congruent? Triangle ABC congruent to triangle CDA. Ooh, I'd like to hear this one from somebody. We just had 3 congruent to 4. What is the method for that one? Yeah, let's go 10. Yeah, because that reflexive, if you just take one of the triangles, that reflexive side is not in between these two. Nice job. And then now BC and DA are congruent. Everyone doing all right? We're going too fast. We all right? Just got to make sure. BC and DA, because this is, as you can see, it wasn't the easiest proof, and we're still not done. And now prove it's a parallelogram. Let's not start this proof from scratch. What have you already done? I've done BC congruent to AD. That's one pair of opposite sides. Or stop, because this is good review for the quiz. You've already proven BC congruent to AD. What else would transform this into a parallelogram? One thing, Connor. The other pair congruent, or proving the congruent pair parallel. You have a choice, and you know what? We can do both. We have enough info to do both. All right, we can prove the other pair of sides congruent or the same pair parallel. Anybody? Parallel or congruent? Where are we going? Where are we going? How many congruents do I have in the house? All right, we win. Here we go. We're going congruent. How do I get them congruent? They already are. By? I can add that into that step. BA congruent to CD. And now I could say it's a parallelogram. Method why this one is, here we go. Oh, let's hear from 18. Let's roll. Why is this now a parallelogram? Nice, nice. Got to hear that word opposite. Oh, wait a second there, kiddos. What course are we in? Yeah, honors. How would you make these pair parallel? You guys that wanted to go parallel, how do I make these parallel? What's up, Gabe? Remember when we proved 3 congruent to 4 by CP/CTC? Those are alternate interior, which imply I have parallel lines. Yes. All good. Questions? All right. You and your group are now on for this one. I will write my version up here and black it out until I see most people are ready to go, and then I'll reveal it. Talk it over with your group. This, as you know, this is not going to be the easiest. Okay, thank you. Okay, let me show you my proof. My proof's wrong. Okay, my proof is wrong. I want you to show me where I went wrong. Okay, I just wanted to up the difficulty level a little bit. Okay, and I want you to figure out where my proof is wrong. Ready? There's no grammar mistakes. Oh boy, Teddy, here we go. Well, I needed this before I wrote they bisect each other. So, okay, ready? What's the property about the diagonals of a parallelogram? That they do what? One more time, they do what? It doesn't say the individual pieces are equal, does it? That's not what the property says. And that's what I'm saying here. I'm saying, oh, those two pieces are equal because it's a parallelogram. No, 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 no. The property says what? What's the property say? So I need to say that in this step, AC and DB bisect each other. That's what the theorem is saying. It's not saying the two little pieces are equal. It's saying the diagonals bisect each other. Then from here, I'm going to have to put in a step 2.5. Now I could say what? That AF is congruent to FC, not because it's a parallelogram, because what have we been using all year? Definition of a bisector. All right. So I just wanted to make that point right there that the property does not say the two individual pieces are equal. It just says they bisect each other. Definition of a bisector says the two pieces are equal. Okay? We okay on that one? All right, so everyone sees now how this theorem can be used. Just to say diagonals bisect each other, not to say the individual pieces are equal. Questions, comments, any concerns from you guys? You'll notice some of it's out of the packet, some of it's out of the book. All right, some of it's out of the packet, some of it's out of the book. The book part is all review for tomorrow's quiz. So I definitely make sure you're on top of that one. All right, there's only 2 proofs, and then the book work is a review for the quiz tomorrow. All right, let's get to it. We got over 10 minutes, so let's get to it. Do not forget about your extensions and